Namaste and welcome to Apna Gurukul Maths. We are discussing now the exercise 6.1, that is lines and angles. All the exercises we will be discussing. One or two problems I'll explain in detail. The other one I will tell you how to approach the answer. That is all is the objective of this particular video. And before I start this video, I just want to tell you that whenever you are approaching the problems regarding the proof or your the problems like this, which you can see it on your screen, always remember, whatever steps you take, you must tell the reason for that particular step. That is always a must and a compulsory thing when it comes to solving problems like this. So let's get into the problems like this very quickly. So as you can observe, the problem over here says that in figure 6.3, line AB and CD intersect, and though over here we have two lines, CD and AB. Okay, they intersect at this particular CD and AB. I guess I told CB. Okay, CD and AB, they intersect at the point O. Now if angle AOC plus BOE is 70, that means angle AOC, that means this particular angle, and this particular angle BOE, they both add up to 70. Now individual measurement is not known, but collectively they add up to 70 degrees. So this angle and this particular angle. Yeah, I hope the question is clear. Now it is given that BOD equals 40 degree, BOD equals 40 degree. So find the BOE and reflex of COE. Now what is the meaning of reflex? Let's try to understand that first. First angle we have to find is BOE. This angle we have to find it out. Reflex of COE. This is the COE angle. Reflex means the other part of this angle. That is 360 minus COE will be the reflex of COE. I hope the question is clear. Let's quickly understand how do we approach this problem. As we can see over here, these two are given as straight lines. So since this is 40 degrees, this will also be 40 degrees vertically opposite angle. I hope that is clear. After that, since this particular angle and this angle is given to be 70, added to be 70, so 70 minus 40 will give you this angle, 30 degrees. Now, since AOB is a straight line, 40 degrees, 30 degrees and angle COE will make 180. So 40 plus 30 plus I'll take this particular angle as X. So X equals 180. So when you solve this equation, you will get X equals 180 minus 70. That will give you 110 degrees. So we have already found BOE, which is 30 degrees. So X will be, now X is 110. So what will be reflex of X? X is nothing but angle COE, right? Reflex of COE will be 360 minus 110. So that is how you get 250 degrees. So reflex of COE will be 250 degrees. I hope that makes sense very clearly. Okay. So now if the how to approach the problem is clear, let's try to understand how do we write it, because the presentation is also very important when we get questions regarding the proofs. Okay, so as you can observe, how do we start? Given condition, first we will write AOC plus BOE equals 70 and BOD equals 40 degrees. Now as you can observe, AOC plus COE plus BOE. Now all these three will add up to 180 degrees. Now always remember, whenever you wrote the statement, you must write the means reason as well. AOB is a straight line and using linear pair axiom. Now since AOC and BOE is 70 degrees, the equation becomes 70 plus angle COE. Yeah. So angle COE will be nothing but 110 degrees. So we have found the angle COE. And then as you saw, we talked about the vertically opposite angle, the same thing. AB and CD intersects at O. So angle AOC equals BOD, which is vertically opposite angle. So that implies AOC is 40 degrees. So since BOD is 40 degrees, yeah, over here BOD is 40, right? So vertically opposite angle, this will also be equal. So that is how we get AOC also as 40 degrees. Now since we know that BOE will be equal to 70 minus AOE, because it is given in the question itself that AOC plus BOE is 70. So BOE will be 70 minus AOC. That is what we are using over here. Now AOC we just now found 40. So that is how BOE is 30. Now we need to find the reflex. So reflex, as we have already observed, 360 minus COE, 360 minus 110, you will get it as 250 degrees. I hope you are very much clear with this question. Second question, let's try to focus on. Second question says, XY and MN intersects at O. XY and MN intersects at O. Yeah. So if POY equals 90 degrees, POY equals 90 degrees, so we have to find angle AB, sorry, we have to find C if A is to B equals 2 is to 3. Try to understand. Now over here, A is to B ratio is given. Whenever the ratio is given, we need to have common factor. If you have forgotten what is common factor, let's quickly go through it. For example, if you have a fraction 12 by 14, okay, so its ratio, what will be this ratio? We will simplify it, right? So if we simplify, what do we remove it? What do we what is the common factor in numerator and denominator? It is 2, so it becomes 6 by 7, right? So the ratio will be 6 is to 7. Now ratio is 6 is to 7, but the actual values were 12 and 14. We removed one common factor, that was 2. So over here, that is very much clearly known because we know it is 12 by 14. But over here, only the ratio is known. The common factor, what is being removed, that is not known. We need to find that. So we will take that common factor as x. So this particular angle will be 2x. So angle A will be equal to 2x and angle B will be equal to 3x. I hope that makes sense. Now, since POY is 90 degree, according to linear pair, angle POX will also be 90 degrees, and A plus B is nothing but angle POX, which is nothing but 90 degrees. So PAB we will substitute, so 2x plus 3x equals 90 degrees. So 2x plus 3x is nothing but 5x equals 90 degrees. X equals 90 divided by 5, and then we can when we uh, cut it out or divide it, we get 9 and 1 18. So x equals 18. So what was the value of x? X was the common factor. Now what will be the angle A? Angle A will be 2 times 18. So 2 times 18 is 36. So angle A is 36. Angle B will be 3 times 18, that is 54 degrees. Yeah, I hope that makes sense very clearly. Let's get going to the next part. Now try to observe, we have to find the angle C. Okay, now there is a very good understanding we can take over here. MN is a straight line, or we can also say MON is a straight line. Since it's a straight line, angle B and C will make a linear pair, right? So B plus C will be 180 degrees. So since angle B we have already calculated as 54 degrees, so C will be 180 minus B, so which is nothing but 180 minus 54. So you will get the angle C, which is equals to 6, 10 minus 4 is 6, 7 minus 5 is 2, and 126 degrees. Yes, I hope this is very much clear for you. Now, you need not write in such a clumsy manner. I'm just making you understand how to approach these problems. You can write a lot in the way we have done the first question. Okay, let's go to the third one. Third one is very easy problem. Let's try to understand. If you are seeing it for the first time, it might not look that easy, but yes, let's try to take a look at it. So in figure 6.15, it is given as this angle and this angle are equal. Then we have to prove PQS, that means this particular angle, and PRT, this angle, they are equal. Yeah, so these two angles we have to prove as equal. These two angles are given to be equal. So since they are equal, we'll give them a value. We'll give them that they are A degrees. So once they are A degrees, let's try to understand, and then we will give this as X and this as Y. So now we will write, since ST is a straight line, ST is a straight line, and Q are points on that. So X plus A will make a linear pair. So X plus A is equals to 180 degrees. What is the meaning of that? X will be equal to 180 minus A. Yep. Now again, since R is a point on the straight line ST, once again at these vertex we are forming two adjacent angles which are forming straight line. by linear pair axiom. So over here, when you are writing the answer, you must mention that you are using linear pair axiom. So once again, y plus a equals 180 degrees. What does that imply? That y is equals to 180 minus a. As you can see, if RHS of two equations are equal, the LHS must also be equal. That is what is an axiom in Euclid's axioms and postulates chapter. So since x equals y, we can say that angle PQS equals angle PRT, hence the proof. That is all we wanted to do. Yeah. So hence the proof. Okay. Let's get going to the next question. Next question says in figure 6.16, if x plus y equals w plus z, x plus y equals w plus z. Now, my dear students, over here, you cannot use linear pair axiom. Why? Because it is not given for us that they are straight lines. Over here, we have to prove that AOB is a straight line. I hope that makes sense. Okay. So, let's try to understand. Over here, the given condition is x plus y equals w plus z. So now, as you can see, if what is the observation over here is from the vertex O, there are different rays coming out. Yes or no? So if there are different rays coming out from the same vertex or same point, what what understanding do we have? That they forms a complete angle. This we already know. So we will write x plus y plus z plus w equals to I will not write it like this. I will write it in a little bit different way, which will make it little easier for us to understand. X plus y plus w plus z equals to 360 degrees. You can mention the reason. Since O is the origin point of all the rays, it forms a complete angle. Yeah. So now understand, in the given question, x plus y is given to be w plus z. So instead of x plus y, I will substitute w plus z. And already I have w plus z over here. I hope that is clear. That is equals to 360 degrees. I'll repeat again. Instead of x plus y, since x plus y equals w plus z, instead of x plus y, I substituted w plus z. And over here, w plus z is as it is. We have not changed that position. Now we get 2w plus 2z equals 360 degrees, and 2 times w plus z is equals 360 degrees, because we can take the two common factorization method, greatest common factor, we take it out. So w plus z is equals 360. Now 2 is in multiplication, over here it will come in division, so it gets us to 180 degrees. So w plus z equals 180 degrees. They are adjacent angles. OD is the ray, so AOB must be a straight line by converse of linear pair axiom, and hence the proof. I hope that makes sense. I hope how did we prove it? That is also clear for you. Now, the next question in figure 6.17, POQ is a line. POQ is a line. It is given. Ray OR is perpendicular to PQ. OS is another ray. OS is another ray lying between the rays OP and OR. So we need to prove that ROS, angle ROS, that means this particular angle, is equals to half of QOS. QOS is this angle. QOS minus POS, minus POS. Okay, this is the angle. So if you subtract these two angles and do a half of that, we will get this particular angle. That is what we have to prove it. So let's try to go step by step. Okay, now what do we understand here? As you can see, this is 90 degrees. This particular angle is 90 degrees. That means if I take this angle as A and this as B, angle A plus B must also be 90 degrees, because POQ is given as a line. So A plus B plus 90 is 180. So A plus B will be 180 minus 90, that is equals to 90 degrees. I hope that makes sense. Now, what is the value of angle QoS? So angle QoS equals B plus 90 degrees. Yes or no? Then what? Try to understand how am I doing it. ROS is nothing but angle B. So what we have to prove, we have to find a relation between B half of QOX. As you can see, we have B plus 90 minus POS. POS is A. Now, whenever you find such proof problems, one of the easiest method is name the angle so that you don't have to write it again and again. Wherever the equal angles are there, you can write the same measurement. Okay, take the variables. So as you can observe here, we have these two these two equations. So I will write it in a little bit different manner. So first one, can I write it as 90 equals A plus B? It's just the equal to sign, right? So now over here, I will not change this QoS. I will let it be QoS so that it's easier for us to prove. Okay, that you can do it even in that way, but it is going a little bit bigger. That is why I changed it to once again QoS. Now over here I have equation number 1 and equation number 2. Let's add these two equations. So what will we get? Angle QoS plus 90 equals, uh, as you can see, B plus 90 plus A plus B. Yes or no? So over here, B plus B, I'll rewrite it here. So it becomes angle QoS plus 90 degrees is equals B plus B over here on the right hand side. So I'll get 2B plus 90 minus A. Yes or no? Plus A. So over here, as you can see, I need B alone on one side. So I'll keep B here. I'll take everything else on the other side. So angle QoS plus 90 minus 90 minus A equals 2B. So plus 90 and minus 90 goes away. So I'm left with angle QoS minus A equals 2B. I'll take this 2B to the other side. I'll get 1 by 2 QoS means angle QOX minus A equals B. As you can see, oh wait, as you can see very clearly, this is what we were looking to prove. Yes, so that is why I told, when we give the values, it becomes a little bit easier for us to prove such questions. You can quickly take a note of this. I've written it in a little haphazard manner, but you can try this way and prove it. This is very easy. This becomes a little bit easier question when we attempt it like this. Okay, so now let's approach the last problem of this particular exercise, then we'll move to the next one. So over here it's given that XYZ is equal to 64 degrees. So over here we have an angle which is XYZ. Okay, I will name it as XYZ. This angle is 64 degrees. That is how we construct a figure, because in this case the figure is not given, and xy is produced to point P. So this xy is being produced to a point P. Okay, I'll mark this as point P. This is point P. Wait, I'm writing with the scale. Point P. Then draw a figure from the given information. Now, if ray YQ bisects ZYP, so there is one more ray which is bisecting this particular angle. So bisecting means it is dividing in two equal halves. So I'll make an approximate angle which is bisecting it. I will name it once again A and A. Okay. Now find XYP. XYP. And wait. Yeah, XYP. Wait, Z, find XYQ. Why am I reading this a little bit bad? Okay, YQ is the line segment which is bisecting. So we need to find this particular, and then reflex of QYP. So QYP is this angle. So we need to find this particular angle. Okay, so let's quickly understand how do we approach this problem. Okay, let me change the color of the ink. Let me take it a little above. Now, as you can observe, this xp is a straight line. Yes or no? Why is it a straight line? First of all, because it is given that it is produced. When it is produced in a straight line. That is what the geometry says. So now it is a straight line. That means these three angles will form a linear pair, or they will sum up to 180 degrees. So 64 plus A equals 180 degrees. 64 plus 2A equals 180. 2A equals 180 minus 64. So what is 180 minus 64? Quickly calculate. So you will get 10 minus 4 is 6. Carry over. This becomes 7. 7 minus 6 is 116. So 2A is equals 116. So A will be equal to 116 divided by 2, which gives us 58. So A is equals to 58 degrees. I hope that is very much clear. Now, what angle we need to find? We need to find ZYP. ZYP. So that means this particular angle we had to find. So this is nothing but A plus A, 2A. So we have already found it as it is 160 degrees. Wait. Oh my goodness. Find XYP. So XYQ. Has happened to me? XYQ is this angle we have to find. So this is 64 plus 58. So whatever value you get, that will be the answer. So 64 plus 58, if you add it, 8 plus 4 is 12, carry over 1, 6 plus 5 is 11, plus 1, 12. So this particular angle is 112 degrees. Okay. Now, we need to find the next angle. We need to find reflex of QYP. So QYP, that is this angle we need to find. So this angle is 58 degrees, obviously, because 8 is 58. Now if we need to find the reflex, just subtract it from 360, you get 302 degrees. So the other angle what we have found is 302 degrees. If you have understood this problem, if you find it a little difficult to understand, you can go back to the video, watch it once again. You will be able to understand it very, very clearly. So if you have any doubt in exercise 6.1, you can comment down, and we can discuss on that particular topic. So now let's move on to exercise 6.2. We will start with the example problems, and I have taken the exact solutions from textbook as well. Okay. So over here it says in figure 6.24, if PQ is parallel to RS, PQ is parallel to RS, MXQ, that is this particular angle, is 135 degrees. MYR, that means this particular angle is 40 degrees. We need to find XMY, this particular angle, we need to find it out. So what is the process we followed? We just now have read in this particular chapter that if two lines are parallel to the same line, the other two lines will also be parallel. For example, this is the line, and I find a line which is on top, which is parallel to this line. Okay, which is parallel to this line. And then once again, I find one line over here which is parallel to the same line. For example, if I had this line L is parallel to M, and L is also parallel to N. Then M and N will be parallel. So this is what is the theorem which we have proven in this particular exercise. So that is what we will be using. So what did I do? At this M point, I draw a straight line AMB, okay, which is parallel to PQ and RY, okay, RS. Once they are parallel, observe it very carefully. How do we proceed to answer this question? Over here, when the PQ is parallel to AB, as you can observe, this line, if you extend it a little bit, it acts as a transversal, right? So once this is a transversal 135, and this we will take it as angle not as X, we will take it as once again A. So angle 135 and A will be supplementary. So angle A, if you have to find, that will be 180 minus 135. So you will get it as 45 degrees. So A is 45 degrees. Yep. Now we will take the another angle. Here now AB is parallel to RS. Obviously it is because of the theorem, you can tell that. And let's take this MY as the transversal. So as you can observe, this is 40 degrees, alternate interior angle. This is also 40 degrees. So what does the question demand? Question demand XMY, this particular angle. So if you have to find this angle, just add 45 and 40, you will get 85 degrees. I hope that is very, very much clear for you. So angle XMY equals 85 degrees. Let's move to the example number 5. Now, this particular example is a little bit confusing, but yes, we need to understand it. So I will explain it. Please listen to me very, very carefully. Now, I'll tell you a very, very beautiful way to understand this question. So you will have lots of fun. So it says, if the question understanding is very important over here. If a transversal intersects two lines, here, it is only mentioning lines. It has never told two parallel lines. That is the first idea we need to be clear. If a transversal intersects two lines such that the bisectors of a pair of corresponding angles are parallel. So suppose this PQ and RS are the two lines and AD is the bisector. Okay. Now, if AD is the bisector, what will one pair of corresponding angles? So I'll tell these pair of corresponding angles. Now, since they are not parallel, PQ is not parallel to RS, we cannot say that these two angles are equal. Okay, so let's begin. What does the problem say next? It says next that these corresponding angles has angle bisector. These are the angle bisector. What are angle bisector? It is dividing these angles into two equal halves. So what can I take? I can take this as small a, so this will also be small a. I'll take this as small b, so this will also be small b. Yes. Now, corresponding angles are parallel. It is also given that these two angles are parallel. These two lines are parallel, that is angle bisectors. Then we need to prove that the two lines which we started with, that is PQ and RS, are also parallel. So we have to prove that PQ is parallel to RS. Let's try to understand how. How can we prove the parallel? We have learned theorems and their converse as well. If somehow we are able to show that their corresponding angles are equal, or their corresponding angles are equal, or interior angle on the same side of transversal is supplementary. Either of the three, if we are able to show, we can clearly say that they are parallel to each other. Okay, so let us begin. Over here we have been given that these angle bisectors are parallel. So now observe it very carefully. Now I'll extend these angle bisectors. I will take orange color. I will extend these angle bisectors. Focus very carefully. Now once I extend these angle bisectors and I'll take this particular side AD as the transversal. So now observe, what can you say about this angle A and this angle B? They are corresponding angles, right? You need to mention where you are taking. So you can take this line as L and M. Since L is given to be parallel, when we take AD as the transversal, A will be equal to B. Yes or no? So what does that imply? 2A will also be equal to 2B. Yes or no? That's very, very common. If A equals to B, I'm just multiplying 2 on both the sides. So 2A equals to 2B. Now try to observe. Now what did I see over here is, now I'll consider these PQ and RS as the side. Once again, AD as the transversal. So these are corresponding angles, right? Corresponding angles according to our measurement which we have given as variables, it is 2A and 2B, and we have already shown that 2A equals 2B. So by converse of corresponding angle theorem, we can say that PQ is parallel to RS. Wasn't it easier? It absolutely is easier. So you can follow this method. It is not, it is completely correct, but yes, once you assume this value A, you must write in the first itself that angle ABE is taken as A. Okay, once you have done with that, you can follow this method very, very easily. I find that this might be very helpful. That is why I have taught a little bit different method from what is discussed in our exercise example NCERT textbook. Okay, I hope that makes sense. Now let's quickly go through the example number 6. Example number 6, as you can observe, it says in figure 6.27, AB is parallel to CD. Okay. And CD is parallel to EF. CD is parallel to EF. Also, EA is perpendicular to AB. EA is perpendicular to AB. Now, if angle BEF is 55 degrees, BEF is 55 degrees, then we need to find XYZ. Now, try to understand. If I take, now you can just rotate this particular figure. I'll rotate it. That's the best thing. Okay, I will rotate this figure. So I will rotate it. Okay. Once I rotate it, it becomes very easy, right? Now, as you can see, this is parallel to this particular angle. Yeah. Now, once this is parallel, I'll take this as the transversal. So 55 and Y, what is the relation? Angle on the same side of transversal. So they will be supplementary. So what is the value of Y? Y will be 180 minus 55. Okay. So 180 minus 55, you get 10 minus 5 is 5. 7 minus 5 is 2 and 1. So this is 125 degrees. Now once again, this particular line is parallel to this particular line. So I'll not, this CD is parallel to AB. And I'll once again take this as transversal, that is line BE. So what is the relation between Y and X? They are corresponding angles. So X will also be 125 degrees. That's all. Now we need to find the value of Z. Since first line is parallel to the second line, means EF is parallel to AB, this particular angle, and this will be supplementary. So since this is 90 degrees, this will also be 90 degrees. So that means Z plus 55 degrees is 90 degrees. So Z is equals 90 minus 55. So 90 minus 55, 10 minus 5 is 5, carry over 1, 8 minus 5 is 3. So we get 35 degrees. So Z is equals to 35 degrees. So we found X and Y are equal. So X equals Y equals 125 degrees. And Z is equal to 35 degrees. Yeah, that is very, very much clear, I hope. Yes. So now let's move on to exercise 6.2. There are 6 problems in this. So this will take more 15-20 minutes. Let's get going. So now find the values of X and Y over here. Very easily understand. 50 and X forms a linear pair. So X will be 130 because 180 minus 50 is 110. X and Y forms alternate interior angles. So Y will be 130. That's all. You just need to mention the reasons why you are writing this. Okay. I'm verbally telling you, when you are presenting it, you can write the answer. Now, as you can see, AB and CD are parallel. CD and EF are parallel. That means AB will also be parallel to EF, and all the 3 lines are parallel to each other. We can say according to the theorem 6.6, which we have. There's already a video. You can look into the description. I'll mention the playlist so that you can go and see all the similar videos and all the concept videos. This is only problem solving video. Now again over here it's given Y is to Z is 3 is to 7. Okay, Y is to Z is 3 is to 7. Once again, I've already told you common factor. So that means Y will be 3. I will not take X because X is already there. A as the common factor. And the value of Z will be 7A. Okay, now try to understand. Over here, X and Z, what is the relation between them? If you take AB is parallel to EF, then X and Z are equal or not, because they are alternate interior angle. So X equals Z. That is the first equation we got. Now, if you take AB is parallel to CD and the same transversal, X plus Y will be angles on the same side of transversal or co-interior angles. So X plus Y is equals 180 degrees. Now, as you can see, we have the values of Y and Z. So since X equals Z, instead of X, I will put it at Z plus Y equals to 180 degrees. Now, what is the value of Z? 7A. A is the common factor. You must mention that A is common factor. Then Y equals 3A. That is equals to 180 degrees. So 7 plus 3a is 10a equals 180. So a will be equal to 18 degrees. Now a is 18. So what will be the value of angle y? 3 times 18. So that is equals to y equals angle y equals, or I'll write angle y equals to 54 degrees. Z is equals 7a. That means 18 multiplied by 7. We'll calculate in rough. 8 times 7 is 56. Carry over 5. 7 ones are 7 plus 5, 12. So that there we get angle Z equals to 126. And we already know it is equal to angle X. So we have found all the three angles. It's very, very, very easily found. Okay, I hope that makes sense. You can take a snap or you can solve it on your own as well. Question number 3. In figure 6.30, it says that if AB is parallel to CD, AB is parallel to CD, EF is perpendicular to CD. That means it is making a 90 degree. And GED, angle GED, okay, GED, this particular angle is 126 degrees. Then we need to find angle AGE. I will represent with purple. We need to find angle AGE. AGE. Okay, this angle we have to find. Angle GEF. Okay, this angle we have to find. And angle FGE. Okay, this particular angle. Okay, let's begin. Since this is given as 90 degrees and this whole angle is given to be 126, this cutty angle, small angle over here can be written as 126 minus 90. That's also 6. 12 minus 3 is 36. Why can we do that? Because 90 plus this angle forms 126. So if you want to find this angle, 126 minus 90, you can make the equation also. So this particular angle, which is GEF, the second one, with 36 degrees. I hope that is clear. Coming to AGE. AGE, as you observe, if AB is given to be parallel to CD, take G as the transversal. So this particular angle, then they are alternate interior angles. So they will be 126 degrees. And as you can observe, there is a linear pair formation. So this FGE angle will be 180 minus 126, which gets you to 10 minus 6 is 4. 7 minus 2 is 5. So you get 54 degrees as the value over here. Okay. And the value of AGE is 126 degrees. Just keep mentioning the reason. No, all the variety of problems can be dealt. Now, once again, for figure number 4 says PQ is parallel to, this line is parallel to ST. Okay. PQ is parallel to ST. Then it says angle PQR equals 110, as you can see, and RST equals 130. So we have to find QRS. QRS, that means this angle. So what we will do, we will extend these parallel lines. Okay, we have extended it. Now try to observe. When you extend it, this is parallel and this particular line is transversal. So if this is 130, this will be corresponding angle. Yes or no? Now, try to observe what else can we do. If I take one more parallel line, which is parallel to PQ and PQ and ST already. Okay, so I drew one more parallel line. You can name it according to your choice. Then, as you observe this particular angle, this angle, what will be that? As you can see, they are forming a linear pair because angles on the same side of transversal or co-interior angle. So this will be 50 degrees. Similarly, over here, as you can observe, this is also making a co-interior angle. So 110 degrees, if that is the measurement, this will be 70 degrees because 180 minus 110 is 70. So can I say, suppose QRS, I'll take it as angle A. So 70 plus 50 plus angle A equals 180 degrees, linear pair formation. So A will be 180 minus 120, that is equals to 60 degrees. So we have found the angle, and that is how we get to this angle and we reach the final answer. Let's go to the next question. Figure 6.32 says if AB is parallel to CD, Angle APQ is 50 degrees. Angle APQ is 50 degrees and PRD is 127 degrees. PRD is 127 degrees. So we need to find X and Y. Very, very carefully understand. If AB is parallel to this, if the AB is parallel to CD and PQ is transversal, this is 50. So X is alternate interior angle. This will also be 50. Yes or no? Then try to understand if now I'll change the transversal. PR is the transversal. So this 127 degrees has an alternate interior angle of this, so which is 127 degrees. So as you can observe, 50 plus y is nothing but 127 degrees. So y will be 127 minus 50 degrees. So that is equals to uh, 7, 12 minus 5 is 7, 77 degrees. So y is equals to, so x equals 50 and y equals to 70 degrees. Okay. I hope that is very, very much clear to you. Now the sixth question and the next exercise, we will do it in the next video because this video has become a little bit longer. So we will wait for the next video, and then sixth question and the next part of the exercise 6.3, we will do it in the next video. Thank you so much for your patience hearing. I hope you enjoyed this particular problem solving session. There'll be some more and many more, I would say, problem solving sessions apart from NCRT as well. Thank you so much for your patience hearing. See you in the next video. Until then, keep smiling. Jai Hind.